Well, hey everybody, Mr. Reeves back with you, and as promised, we're going to be, uh, I'm going to be rather, helping you learn to write two-step equations. All right, so this is lesson 6.3 in your Math 7 textbook. So we have been solving two-step equations, but many times we need to do some problem solving, so we need to know how to write two-step equations. All right, so sometimes the easiest way to learn is just to look at some problems. All right, so it says here you can write two-step equations to represent real-world problems, translating the words of the problems into numbers, variables, and operations. So what we have to do is learn to take the information from the words and turn them into numbers, variables, and operations. So it says here in example number 1, a 1-year membership to the Metro Gym cost $460. There is a fee of $40 when you join, and the rest is paid monthly. Write an equation to represent the situation that can help members find out how much they pay per month. All right, so we're going to have to know several things. When you write an equation, you're going to have some kind of total. You're going to have something that it equals. All right, in an algebraic equation, we're going to have an unknown. That's what our variable is going to be. And in these ones that are modeled by two-step, usually there's some kind of one-time fee and then something that is reoccurring. All right, so let's start by finding out what it is that we don't know. That'll help us figure out what the variable is. If you look at step 1, it says identify what you are trying to find. Well, usually what you're trying to find is in the form of a question. All right. It says here, write an equation to represent the situation that can help members find out how much they pay per month. So in this case, they didn't write it as a question, but they told us what it is we're trying to find. How much they pay per month. So it says right here, let M represent the amount of money they pay per month. Okay, and then they take this problem down and they break it up into its parts. You have that one-time fee of $40. It's important that you only pay it, you know that you're only paying it one time because it's not going to get the variable. All right, because it's a year and there's 12 months in a year. Remember, M we said was the amount they're paying per month, so we need to multiply that by 12. And then the total cost for the year is $460. So you can see right here your equation that you get is 40 plus 12m is equal to 460, or you could write 12m plus 40 is equal to 460. Again, if we break this down, m, that's our variable. That's what we didn't know, the cost per month. We have to multiply it by 12 because there are 12 months in a year. There's our one-time fee, and when we add all of that money together for a whole year, it is 460. Of course, to solve this, we would subtract that 40 away, and then we would divide by 12, but they're not asking us to solve it. Okay, so let's take a look at this one right here. Here we go. It says Billy has a gift card with a $150 balance. He buys several video games that cost $35 each. After the purchases, his gift card balance is $45. Write an equation to find out how many video games Billy bought. So do you see right there what we're trying to find out? Find out how many video games Billy bought. All right, so that's going to be our variable. So how many games he bought, I'm going to let that right there be, let's do G. So G is the number of games bought, okay? Okay, and remember we're looking for a total, all right? This is $150 balance. That's where he is starting, right? Okay, if we take a look, we've got his card balance. That means the amount that's left. Okay, so that's the amount that's left. So in this case, that is our total because we're actually not going up, we're going down. And then $35 each. That is our reoccurring cost. I think this is how you spell reoccurring. All right, and remember the reoccurring cost, that's what gets the variable. So if we put all this together, we have $150. That's what Billy started with. All right, the amount on his card will go down. How much is it going down by? $35 every time he uses it. All right, the number of games he buys is G, and when he's done, he has $45 left. Okay, so he started with $150. It's going down $35, but it's going down $35 for every game he buys. We don't know how many. And when he's done, he has 45 left. And again, they didn't ask us to solve it, but if they did, we would take away that 150, and then we would divide by that negative 35. Okay? All right. And sometimes, by the way, they're going to they're going to give you an equation and ask you to come up with a way to explain what it means. Okay? So just remember, when you see a number in front of a variable, that is something that is reoccurring. So if you take a look at what they have, all right, X number of books, 5 pounds, right? So you have books and every book weighs 5 pounds, so that could be 5X, or X number of weeks, and you're saving $5 each week, all right? And that part that does not have a variable, that's a one-time fee. And then over here is some kind of total. When it's going up, it's a total. When it's going down, it's like a balance. What's left? This one's going up. All right. So for example, if we were to use that savings model from there, you could have $50. All right. So you had $50 already, and you're saving $5 each week. How many weeks until you had $120? That would be an example for that problem. Again, you started off with 50. That's that one time thing you have. That $5 is repeating every week, and there is your total. All right, these problems are all going to be kind of very similar. All right, this one right here, again, if you were saying, okay, again, if we're looking at that same situation, this time you started off with $40 and you were saving $10 each week, how long until you have $100? All right, or maybe an elevator can hold at most 100 pounds. There's already 40 pounds in there, and each item you're adding is 10 pounds. How many items can you add before you reach that maximum of 100? It'd have to be a small elevator, by the way, if it only holds 100 pounds. All right, maybe some kind of little in-house cargo elevator or something. Maybe you're just pulling a rope and you can only pull up to 100. Alrighty, so let's look at a few more problems, and then this video is going to be done. Alright, so here we go. Val rented a bicycle while she was on vacation. She paid a flat rental fee of $55. So there's that one-time thing, plus $8.50 each day. There's that recurring thing. The total cost was $123. Write an equation you can use to find the number of days she rented the bicycle. There we go. The number of days she rented the bicycle, that is our variable. Okay, so that right there is going to be D. All right, so let's start with that one-time fee of $55 plus $8.50. That's our reoccurring fee. How often is it recurring? Every day. And then we have our total of $123. So again, one time, there's our reoccurring, which gets the variable, the number of days, $8.50 per day, and there is our total. All right, a restaurant sells a coffee refill mug for $6.75. There's that one-time fee. You buy that mug once. Each refill costs $1.25. There's that reoccurring fee. Every time you go in and get a refill, you're paying $1.25. Last week, he spent $31.75 on a mug and refills. There is our total. Write an equation you can use to find the number of refills that he bought. There's our variable. The number of refills is going to be R. All right, so we have our one-time fee, which is $6.75, right? Plus our reoccurring fee of $1.25. That's what gets our variable, because every refill is $1.25. And then we have our total here, which is $31.75. 5. All right, over here, because it fits on the screen, Heather has $500 in her savings account. She withdraws $20 per week. Withdrawal means to take money out. Write an equation Heather can use to see how many weeks it will take her to have a balance of $200. So how many weeks it will take her, that's our variable, right? So I'm going to let that equal W. Okay, so in this case, it's not a one-time fee. It's the starting amount. Okay, so when things are going down, you have what you started with. A withdrawal is going down. It's going down by what? $20, but not once. It's going down by $20 every week. So there's that reoccurring part. So there's that one time, which in this case is starting. We're going down by $20 per week, and we want to know when she will have 220 left. So this is that total spot, but when it's going down, it's the balance spot. It's the balance spot, okay? Okay, let's look at a couple more, and then we will be done. All right, a gym holds one 60-minute exercise class on Saturdays and several 45-minute classes during the week. Last week, all of the classes lasted a total of 285 minutes. Write an equation you can use to find the number of weekday classes. Okay, so here we go. So 60, there's only one Saturday in a week. So that's that one time occurring. Several 45-minute classes during the week. So that's a reoccurring thing. That's what's going to get our variable. Last week, all of the classes together were 285. There is our total. And then it says write an equation to find the number of weekday classes. Well, that is going to be our variable. All right, and again, I'm going to let that be W. Okay, so here we go. So we have that 60-minute class that is occurring only once, our one-time thing here. Plus, the reoccurring thing is 45-minute classes, and there are W of those. The number of weekday classes is W, and then our total is 285. All right, so see how that works again. It's the same thing over and over again. A one-time occurrence, a reoccurring occurrence that gets the variable, and then a total or a balance. Okay, and by the way, to solve this, we would subtract 60 and then divide by 45. All right, here we go. Last one. There are 172 South African animals in the Springdale Zoo. That is 45 more than half the number of African animals in the zoo. Write an equation that you could use to find N, the number of African animals in the zoo. All right, well, they did one that's a little different here. Write an equation you could use to find N, the number of African animals in the zoo. Okay, so they told us what our variable is. Okay, so there are 172 South American animals in the zoo. So 172, this is the South American. And then it says that is, well, that's the same as that equals. When you see is or is equal to, right? Is equal to, or is the same as, those are all words that mean equals. Okay, those are our equation words. Okay, 172 is equal to 45 more than 45 plus. Earlier this year, we talked about writing expressions. Half the number of African animals. And it said N was the number of African animals. All right, so this part right here, that's the 45 more than, right? And then this part here, that's half the number of African animals. Okay, so the number of South American animals, 172, is 45 more than half the number of African animals. Again, to solve this, we would subtract 45 and then divide by half. Okay, all right, so that's going to end this video on writing two-step equations. Okay, so soon you know what we're going to do. We're going to put this writing and solving together, and we're going to do some problem solving with two-step equations. But we'll save that for next time. Until then, have a great day.